Assalamu alaikum students. This is the third online lectures on chapter 4 partial fractions. In previous lectures we start exercise 4.1 on lecture 1 and lecture 2. We discuss only 6 questions. Now this is online third lecture of exercise 4.1, question number 7. Before starting, first you must see the lecture 1 and lecture 2. Now this is question 7. This is online lecture 3 on partial fraction chapter 4. This is x square plus 2 in numerator, and in denominator this is x plus 2, x square plus 5x plus 6. Before starting this chapter we discussed the cases of partial fraction corresponding to their denominator. Now this is the one of the case in which denominator is linear combination of, this is a linear equation and this is the quadratic equation. So in partial fraction we will first split these into the linear equations. If it is splitted, so this will be easy for us. Now this is the case in which denominator is split or divided into the two partial fractions. Now you can see that this is x plus 2 and x square plus 5x plus 6. So this is not a linear equation. You see that this is x square, so this is not linear. It give us two values of x, because when you can either you can factorize or you can apply a formula which is quadratic formula, or by any other like completing square or any other method. So we are interested to split this thing. Now x square plus 2, x plus 2 is same, and this one will be changed. We will find these type of values in which multiplications will be, in which when we can multiply these values, it's give us 6x square, and when we can add the values it give us 5x. This is a factorization method, or you can say that midterm break. So in many books you can see that this method will be like a factorization, or in some books they used a midterm break. Why we can use midterm? Because we will split this 5x into two values, or we will split this middle values, or a value in which variable power is 1. We will split this value. So that's why we will call it this is a midterm break. Or either we can use factorization, the name factorization as well, because this is also a factorization in which quadratic equation is divided into, or it's may be written in the linear combination of, in a multiplication of two linear equations. Now you can see that this is x square, 2x plus 3x, 5x may be write in 2x plus 3x. Why we can write in this form? Because when we can multiply 2x and 3x, it give us 6x square. So that's why we can use 2x and 3x. In student minds, they may be considered that why we cannot write 1x plus 4x, because when we can add these things, so it also gave us 5x. But why we can write 2x and 3x? Because there are two conditions on it, that its multiplication give us 6x square and its addition give us 5x. So if the two values satisfy these two conditions, not one, because when we can see a factorization method, so here this is some rough work on it. Say like 2x plus 3x, it gives us 5x, and 2x plus 3x, when we can multiply these two values, it's give us 2 3s are 6, and xx, this will be give us x square. Now these are the two values. If students have any doubt on this factorization, so they may be asked in comment section or any other website, on a social media, WhatsApp, any other thing. So now we can move towards other step, like this is x square plus 2x. When we can take common of x, so here this will be just x, and when we can take common x from this value, so it gives us only 2. Similarly, here this is 3x plus 6x, so when we can take 3 as common, so there will be just x, and this is 6, so 6 may be right in 2 multiplied by 3. When we can take 3 as a common from this, so this will be just 2. Now this is the remaining part of this thing. This is x square plus 2. Now this is x plus 2. Here this is a curly bracket, but I think we will miss it. Now this is x plus 2. When we can take x plus 2 common from this thing, this is only single value, this is the another single value. When we can take x plus 2 common from this, so this will be just x. When we can take x plus 2 common from this value, so this is just 3. The numerator will be same. So x square plus 2, x plus 2 and x plus 2, this is x plus 3. This is denominator, and x plus 2, this is same, so this will be x plus 2 square. Similarly, this is x plus 3. Now we can use partial fractions. We can split this denominator partially. This is x square plus 2. Now this is linear equation, but there is a power of 2. So we can discuss the cases in our previous lecture, that if this is x plus 2 square, so the first constant elements, we can find these values a, b, c, but just for a simplification, we can say that x plus 2 power 1, so it's give us like only one constant, so this will be a. For x plus 2, this will be x plus 2 square, so this will be b into x plus 2 whole square. If now this is in this condition, the power is 2, so we can just write up to b. If the power is 3, so it may be like some any other constant, so c is here, we will put d, and in denominators we will put x plus 2 whole power cube. If here this is a power of 3, but in our condition this is just the power 2, so there are only 2 constants over here. Similarly, the third constant corresponding to this value, now this is c into x plus 3. Now multiply both sides by x plus 2 whole square into x plus 3. In the left of the denominator, we can multiply this value into both sides. So if we can multiply x plus 2 whole square into x plus 3 over here, so they will cancel each other. Just x square plus 2 will be the remaining part of this. Similarly, if we can multiply this value x plus 2 into x plus 2 whole square into x plus 3 over here, so x plus 2 whole square and x plus 2, the single value will be cancelled, so there will be just x plus 2 and x plus 3, because this is x plus 2 whole square. If we can x plus 2 whole square x plus 3, if we can write in this form, so x plus 2 will be cancelled, and x plus 2 x plus 3 will be the remaining part. Similarly, when we can multiply x plus 2 and x plus 2 whole square into x plus 3, so x plus 2 whole square x plus 2 whole square will be cancelled out, there will be just x plus 3. So this is the x plus 3 value. Similarly, this is c into x plus 3. If we can multiply x plus 2 whole square and x plus 3 over here, so x plus 2 whole square will be cancelled. Just x plus 2 will be the remaining part. Like when we can multiply x plus 2 whole square x plus 3 over here, so x plus 3 will be cancelled out. Just x plus 2 will be the remaining part of this, so we can write in over here. Now this is equation number 2. Now we can split into x square plus 2. A will be same. We multiply these two values, x and x. This will be x square. So this will be, I think, 2x, and like x square, x and x square, this will be 3x, this will be 2x, and 2 3s are, it's give us 6. Similarly, this is bx plus 3b, and now you can see that this is c into x plus 2 whole square. Now this is the formula, a plus b whole square. Here instead of a, this is x, and instead of b, this is 2. So when we can apply a formula, so a plus b whole square formula will be like a square plus b square plus 2ab. Instead of a, we will use x, instead of b, we will use 2. Now this will be x square plus 2. Here we can use, when we can multiply these two values, so this will be ax square, and 3x plus 2x, it's give us 5x. When we can multiply with a, so this will be 5ax plus 6a, and this will be bx plus 3b. And when we can multiply these values, so this will be cx square, and after that we can write this value, 2 2s are 4, and x, this will be 4x, and 2 square, it give us 4. Now x square plus 2, ax square plus 5ax plus 6a plus bx plus 3b, this is same as above. Now we can multiply this value, so cx square plus 4cx and plus 4c. Now this is equation number 3. Now we can see that this value, that first we will find a saddle points or critical points. You may be asked like a saddle points or critical points. Now x plus 2 whole square and x plus 3, take this value to be equal to 0. Now this is a critical points, or like a CP, or you can say that saddle points or something like that. So x plus 2 whole square into x plus 3, the product of two values is 0. It means that either this value is 0 or either this value is 0. For a safe condition, we will take both values equal to be 0. So x plus 2 whole square is equal to 0. It implies that when we can take square root on both sides, so square will be cancelled out, and square root of 0, this is again 0, and after that plus 2, this is plus 2. When it moves to the other side, this will be minus 2. Similarly, this is x plus 3 whole, x plus 3 is equal to 0. It means that x is equal to minus 3. Now x is equal to minus 2 and x is equal to minus 3 are the two values in which it give us some constant values like a, b or c. First we can put x is equal to minus 2 and then x is equal to minus 3. So let's see. Now this is the equation third, but we can put x is equal to minus 2 in this equation number 2. Now you can see that this is equation number 2. Put x is equal to minus 2 in equation 2. Why we can put x is equal to minus 2 in this equation? Because here we will find easily the values of a, b or c. It's up to you that either you can put this value in this or in this. So but equation 2 is you can see that this is more easy after putting these values. So but you must put in this after simplification. Now this is equation number 3. Why we can take equation number 3? Because there are only 2 points, x is equal to minus 2 and x is equal to minus 3, and there are 3 unknowns, a, b and c. If this is the condition in which the points are, let's say this is 2 and the unknown is 3, so up to this you can find these values and then simplify as much as possible. Like now this is equation number 3, we will simplify equation 2 further. Why we can simplify? Because if the points and unknown are not same, so we can do this thing. Now if we can put x is equal to minus 2 in this equation number 2, so this will be x square plus 2 a into x plus 2. When we can put x is equal to minus 2, so x is equal to minus 2. Now this is the same equation 2, we can write in over here. When we can put x is equal to minus 2 in this equation, so minus 2 plus 2, this will be 0. So anything multiplied with 0, so it give us 0. Similarly, minus 2 power square, so minus 2 it give us 4 plus 2. Now this is b, minus 2 plus 3 it give us 1. Minus 2 plus 3 it give us plus 1, so this will be b into 1. Similarly, minus 2 plus 2, this will be 0, and 0 square, this is again 0, and when we can multiply with any value, so this will be 0. So 4 plus 2, this is 6, and this term will be 0 because of this. Minus 2 plus 2 0, and this term will be 0. Minus 2 plus 2, so this will be 0. So anything multiplied with 0, so this will be 0. And we know that in addition 0 is identity, so that's why 4 plus 2, this is 6, and this is b. It means that 6 is equal to b or b is equal to 6. Now we can put x is equal to minus 3 in equation 2. This is equation 2. I think this is, we can write over here, so this will be more easy for us. This is x square plus 2 into ax plus 2. This is same equation number 2. Now we can put x is equal to minus 3. So when we can put x is equal to minus 3 in each values, so you can see that minus 3 plus 3, this will be 0. So anything multiplied with 0, this term will be vanished. Similarly, minus 3 plus 3, this will be 0. Anything multiplied with 0, so this will be vanished. Minus 3 square, so minus 3 minus 3, when we can multiply, so this will be 9. 9 plus 2, this term will be vanished because of this term. This term will also be vanished. Minus 3 plus 3, this will be 0. Similarly, c into minus 3 plus 2, this will be minus 1 square. So minus 3 whole square and plus 2, so this will be 9 plus 2. For minus 3 plus 3, this term will be finished, this term will be finished. C into minus 3 plus 2, this will be minus 1. Minus 1 square, this is again 1. And when we can multiply 1 with c, so this will be just c, because in multiplication c is multiplicative identity. Now it means that 9 plus 2, this is 11. This term will be finished, this term will be finished. It's give us 0, and 0 is additive identity, so just c is equal to 11. Means 11 is equal to c, or c is equal to 11. This is the another term. First we can find b is equal to 6, and then c is equal to 11. Now there is the another constant a, which is unknown, but the points are finished. Here we can use equation 3. This is a simplified form of equation 2. So first we can write this equation 3 over here, and comparing the coefficient of x square. So this is the equation 3. We can write over here, comparing the coefficient of x square. Now in left side, this is x square plus 2. We know that if there is nothing, so it means that the constant will be 1. So here it is 1. And similarly, when we can see that this is x square, so the constant, coefficient of x square, this is a, we can write over here. Similarly, when we can see another term of x square, so this will be this thing. The coefficient of x square is c, so we can write plus c, and the other terms will be linear or constants. So it means that on the left there is only one term, x square, so the coefficient will be 1, and the two terms are on the right side, so the coefficient of x square is here a, and this is c, so we can write in this form. Now we know that the value of c, this is 11, so we can put the value of c. Hence we know that c is equal to 11. So 1 is equal to a plus, by putting c is equal to 11. So we know that now, I think this is just 1. 1 is equal to a plus 11. When this term will move towards other side, so plus 11 will be changed into minus 11. So this will be a is equal to minus 11 plus 1. Remember that this is only 1, not 11. Now minus 11 plus 1, so it gives us minus 10. Now this is equation number 1. X square plus 2 into x plus 2 whole square, x plus 3. We can put a, b, c values in this equation. This is the value. First we can find the value of b, then we can find the value of c, and then we can find the value of a. We can put in this first equation, in this. So this is x square plus 2, x plus 2 whole square, x plus 3, x plus 2, x plus 2 whole square, and 2x plus 3. these are the values: a is equal to minus 10, b is equal to 6, and c is equal to 11. So by putting a is equal to minus 10, b is equal to 6, and c is equal to 11 in first equation, we get the solution. So this is the solution of question 7. Now we can move toward other question. This is question 8. In KPK textbook you can see this exercise 4.1. Up to this question we can solve 7 questions. In question 7 is solved in this lecture 3 part 1. Similarly, question 1 to question 6, it is already solved. You may see in my previous lectures. Now this is question 8. 2x minus 1, x into x minus 3 whole square. Now 2x minus 1, it is same as it is, so this is linear, so we can write a into x minus 3 whole power is 2. So first we can write x minus 3 and then x minus 3 whole square. So these are the two terms for this, and for just x, this is the only this term. We can use here a partial fractions. So this is 2x minus 1, a into, I think there are some steps. So we can multiply x into x minus 3 whole square into both sides. If we can multiply x into x minus 3 whole square to the left of this, so x into x minus 3 whole square will be cancelled, just 2x minus 1 on the left side will be the remaining part. So this is for moving towards right side, when we can multiply x into x minus 3 whole square to this side, so x will be cancelled, just x minus 3 whole square will comes with a. Similarly, when we can multiply x into x minus 3 whole square with b, so x minus 3 whole square, it means that x minus 3 will cancel each other, just x minus 3 and x will be the remaining parts, so we can write over here. Similarly, when we can multiply x into x minus 3 with this, so x minus 3 whole square will cancel each other, just x will be remain with c. So this is equation number 2. First we can find the values of a, b, c, and then we can put these values in equation 1. Now this is 2x minus 1, a into x square, x minus 3 whole square plus bx into x minus 3 plus cx. When you can take these values to be 0, so it gives us only two terms, like x into x minus 3 whole square, so it means that x is equal to 0, x minus 3 whole square is equal to 0, it means that x minus 3 is equal to 0. When minus 3 will shift to the other side, so this will be positive, so x is equal to 3. Now these are two critical points and the unknowns are 3. So we simplify this equation 2. Let's see, this is 2x minus 1, a into, now this is the formula, x minus 3 whole square, it means that a minus b whole square. So a, instead of a we will use x, and instead of b we will use 3. So a square plus b square minus 2ab minus 2. Here this is 2. A is x and b is 3. So minus 2 and 3 when multiplied, so this will be 6 and x. Here we can use direct formula, but students are requested to find this value, that how we can put x minus 3 whole square into this form. Here we can use the formula x minus 3 whole square. This is same like a minus b whole square. So a minus b whole square formula is a square plus b square minus 2ab. This is a square plus b square minus 2ab. So this is the minus 2ab term. Minus 2, a is x and b is 3. So minus 2 and 3 when we will multiply, so this give us 6. Similarly, x and x, this will be x square, means bx when we can multiply with x, so this will be bx square. Similarly, plus minus bx when we can multiply with 3, so this will be minus 3bx plus cx. Now this is equation number 3. Equation 2 implies that, now this is equation number 2. Remember that in our next page or in our next steps, you may remember this equation 2 and equation 3. So equation 2 implies that this is the equation 2, 2x minus 1, a into x minus 3 whole square plus bx into x minus 3 plus cx. When we can put x is, first we can put x is equal to 0 and then x is equal